Hello everyone. So today I would like to explain about quantum numbers and their types. So before that, do subscribe my channel and share it and comment it. Okay, now we come to our topic is quantum numbers and their types. Okay, first of all, who discovered the quantum numbers means the quantum numbers was first proposed by the Niels Bohr. So according to their rules, we have to follow today. So the types, quantum number types, we have four types divided as. So first one is principal quantum numbers, and second one is azimuthal quantum numbers, third one is magnetic quantum number, and fourth one is spin quantum number. First we have to know the differences between quantum and numbers. Okay, then after we know the quantum numbers definition. Okay, first we know the quantums and numbers. First, quantum means it is an energy. So energy, whatever the energy means, the energy is in their shapes and space and orientation means a spin. Okay, and numbers means to calculate the measure value and accuracy value. Okay, of particular orbitals. So means quantum numbers says that. So it determines the energy of the shapes, space and orientations means spin orientations. Okay, these are quantum numbers was proposed by Niels Bohr. So we have four types of spin quantum numbers and magnetic quantum numbers, azimuthal quantum numbers or angular momentum, and principal quantum numbers we have to see today. So క్వాంటమ్ నంబర్స్ ముఖ్యంగా ఒక ఒక భేదం గురించి చెప్తుంది. ఏంటంటే అది జస్ట్ ఎనర్జీ, ఒక శక్తి అనేది ఎందులో అంటే శక్తి మరియు దూరం, డిస్టెన్స్ ఫ్రమ్ ది న్యూక్లియస్, దాని గురించి చెప్తుంది అనమాట. సో దానికి మనం షేప్స్ కావచ్చు, వాటి యొక్క మళ్ళీ ఎనర్జీ కావచ్చు, మరియు స్పేస్ అండ్ ఓరియంటేషన్ కావచ్చు. నెక్స్ట్ ఇప్పుడు మనం టైప్స్ చూద్దాం. సో క్వాంటమ్ నంబర్స్ యొక్క రకాలు. నా this is the first principal quantum number. Okay, principal quantum number was first proposed by Niels Bohr. Okay, and it is denoted by n. Okay, it is denoted by n, means a main function of principal quantum number is that, so it is the energy or the energy differences in shells. Okay, particularly in shells. So every atom has are covered by the shells. Okay, సో మనం తెలుగులో కర్పరం అని అంటాము. కర్పరాలు, ఉపకర్పరాలు ఉంటాయి ఇందులో. మనకు ప్రిన్సిపల్ క్వాంటమ్ నెంబర్లో ఎక్కువగా కర్పరాలు ఉంటాయి. కర్పరాలు ఎన్ని ఎలక్ట్రాన్స్ అనేవి ఉంటాయో మనకి చెప్తుంది అనమాట. సో అండ్ shells we have some electrons and their energy is differences. So principal quantum number says that energy differences within atom. Okay, so first suppose this is a nucleus covered by the shell, the first shell, K shell, L shell and M shell and L shell here, N shell. Okay, first these are means in main shell మీన్స్ మనం మెయిన్ కర్పరాలు చూసుకున్నట్లయితే ఎన్ అంటాం, ఎంతో సూచిస్తాం దీన్ని. కాబట్టి n ఈజ్ ఈక్వల్ టు 1, n ఈజ్ ఈక్వల్ టు 2, n ఈజ్ ఈక్వల్ టు 3 ఆర్ n ఈజ్ ఈక్వల్ టు 4. ఓకే, సో దట్ మీన్స్ n ఈజ్ ఈక్వల్ టు 1 and 2. These are shells, main shells. If it is a shell is increases and their atom size and nucleus size also increases. Okay, the number of shells is increases and energy also increases. సో మనం ఎక్కువగా ఈ ప్రిన్సిపల్ క్వాంటమ్ నెంబర్ ఎక్కువ మనం ఎనర్జీ గురించి ఎక్కువగా ఎక్స్ప్లెయిన్ చేస్తుంది. ఓకే, మనం దీన్ని ఎంతో సూచిస్తాం. సో జనరల్గా మనం దీన్ని న్యాచురల్ నెంబర్గాతోనే డిజైన్ చేస్తాం. ఫస్ట్ ప్రిన్సిపల్ క్వాంటమ్ నెంబర్స్ ఈజ్ డిజైన్డ్ యాజ్ 1, 2, 3, 4 etc. Okay, this is a 1 for n is equal to 1 first shell, second shell, third shell, fourth shell. That is means K, L, M, N. Okay, KLM, this is a principal quantum number main theme. And next principal quantum number 1, 2, 3 means KLM and shell. These are shells. Okay, this is a principal quantum number. Next we have to see in azimuthal quantum number in the shortcut form AQN, or angular momentum quanta. Okay, so it will designed by Sommerfeld, Arnold Sommerfeld. Okay, Sommerfeld. So it is designed as, or it is denoted by L. Okay, L. So L is a value of angular momentum. It may be, so it is the main function of azimuthal quantum number or angular quantum number means so it is designed as shape of the orbital. Okay, shape of the orbital. ఆర్బిటాల్ యొక్క షేప్స్ని మనం తెలియజేస్తుంది అజిముతల్ క్వాంటం నెంబర్. మనం తెలుగులో దీన్ని కోణీయ ద్రవ్య శక్తి నియతం లేదా క్వాంటం నెంబర్స్ అంటాము. మనం ప్రిన్సిపల్ క్వాంటంని ప్రధాన క్వాంటం సంఖ్య అంటాము. సో మనం ఇది షేప్స్ గురించి తెలియజేస్తుంది అజిముతల్ క్వాంటం నెంబర్స్. ఓకే, అది ఎలాగో ఇప్పుడు చూద్దాం. నెక్స్ట్ నౌ యూ కెన్ సీ ద అజిముతల్ క్వాంటం నెంబర్స్ వాల్యూ L ఈజ్ ఈక్వల్ L. సో L means L is equal to 0 and L is equal to 1, L is equal to 2, L is equal to 3. It indicates what means that, so L is equal to 1. If it is L is equal to 0, it indicates S orbital, and it is L is equal to 2, it indicates a P orbital, and 2D orbital is L is equal to 3, it is indicate F orbital. Okay, this is azimuthal quantum numbers. The indication of L values is 0, so it indicates the S orbital. So S P D F orbital is value of L. So here 1, 0 and 3, and if it is L is equal to 2, it is D. Okay, it has 5 and 7. Okay, these are means 1 here, 2, 3, 0, 1, 2, 3. Okay, now we can see these are the value of azimuthal quantum numbers or angular momentum. So 0, 1, 0, 1, 2, 3 means S, P and D, F. Now we can see the shape of the orbital. Here is a spherical shape and dumbbell shape and double dumbbell shape. On F orbital is a very complicated means a complex, too complex means it is a clover set shape or leaflet shape. F orbital is, it is very difficult to identify. It is a 3 dimensions or it is difficult structure. Okay, F orbital. What means that azimuthal quantum numbers, as quantum numbers are says that there are particular orientations and energy differences. Okay, now we can see the magnetic quantum number. Magnetic quantum number example in Telugu recording as అయస్కాంత క్వాంటం నంబర్స్, అయస్కాంత క్వాంటం సంఖ్య అంటాము, లేదా అయస్కాంత ద్రవ్యనేత. అంటే మ్యాగ్నెటిక్ క్వాంటం నంబర్స్ మనం దేన్ని ఇండికేట్ చేస్తామంటే ఇట్ ఈస్ ఇండికేటెడ్ బై ది ఎల్స్ ఆర్ ఎం, మ్యాగ్నెటిక్ క్వాంటం నంబర్ ఎం sub L. Okay, it is the indication of magnetic quantum numbers. So magnetic quantum numbers main function is to determine the space of the orbitals. Space of the orbitals is value is minus L over plus L designation indication. The formula of N is L is 2L plus 1. So for this formula we can identify the their shape of the orbitals or the carrying electrons of the orbitals. So S orbital, how many electrons are carrying, and P orbitals and D orbitals and F orbitals, how many electrons are carrying, then depending upon this formula 2L plus 1. Okay, now we can derive the further formula to carrying electrons of the orbitals. Okay, this is the formula 2L plus 1. So if it is L is equal to 0, L is equal to 1, L is equal to 2, L is equal to 3, already we know S and P and D, F orbital. Okay, so for this 2L plus 1 we can adding these values. In case of 2, L value of the magnetic quantum number is 0, so plus 1 is equal to 1. Okay, 2 into 0 is 0, plus 1 is equal to 1. And next in place of 1, L is equal to 1 plus 1 is equal to 2. Okay, means 3, not 2, 3. 2 into 1, 1, 2 plus 1 is equal to 3. Okay, in place of 2 we getting 5 and 7. Here in azimuthal magnetic quantum numbers it gives 1, 3, 5, 7. Odd numbers values they are given. Okay, odd numbers values 3, 5, 7 of these orbitals S, P and D and F orbitals. So it is a 1. S orbital contain only 1 electrons, means is equal to 2, 6, 10 and 14. These are the carrying electrons of particular orbitals. S orbitals may be P orbital and D orbital, F orbital. Okay, these are the azimuthal quantum numbers. It gives some values depending upon their formulas. For this next we have missing one point then from the azimuthal quantum angular momentum. So their value is L is equal to 0 or n minus 1. So for we applying this formula, then we adding values for this. L is equal to 0, in 0 plus 0 minus 1, 0. Okay, and if n value is 1, n is equal to 1, 1 minus 1 is equal to 0. So for this value we getting 0 for the azimuthal, means angular momentum. Next we see the spin quantum number. Okay, spin quantum number. Spin quantum number was first proposed by Uhlenbeck and Goudsmit. Okay, they were proposed as spin quantum numbers. So spin quantum numbers was denoted by m sub s. Okay, this is spin quantum number. So every atom has some spin. Okay, it may be high and low spin. This indication what high spin means a spin quantum number. So it indicate means for example I will take one atom, it may be either, so helium atom I will take now. So the helium atom number is 2. So it s orbital contain here 1 and 2. So it indication what electrons is high, this is a high spin, this is a low spin, means value is plus 1 by 2 or minus 1 by 2, means parallel or anti-parallel directions are there. So that means high spin, it is the high spin value, this is a low spin, that means anti-parallel nature. Means helium atom has this is a 1 by 2 plus 1 by 2, this is a minus 1 by 2, this is it is decreases. So this is have low spin, this is have high spin according to their principle. This is spin quantum numbers. Okay, so the quantum numbers they gives only determine as so energy differences of principal quantum number, azimuthal quantum number and magnetic quantum number, and finally spin quantum number. Okay, this is a shortcut form of this. Next, these are the today class hour section. So I hope all of you are understanding well about these quantum numbers and details. So thank you for watching this video.